Alright, so we're going to now deal with solving equations that have the variable appearing on both sides of the equation. So these will be some of the most complex types of equations we will deal with in Algebra 1. With any luck, we covered this in pre-algebra, so this is review. If not, I guess we'll learn now. So the idea here is going to be to combine like terms, if there are any, on each side of the equal sign, and then get all the variable stuff to the left, all the non-variable stuff to the right, and solve. So this says continue using the 6-step process. If we've been in class, you've seen that. If not, it's not a big deal. You'll catch on to what I'm doing as we go. So the first thing I actually am going to encourage you to do is to draw a box around each half of the equation. So the left side of the equal sign and the right side of the equal sign, as I've done here. And what I want you to do is look in those boxes and say, are there any like terms to combine? So in the box on the left, there's a 7k. Well, there's only one term. It has nothing to combine with. In the box on the right side, there's a 4k and 15. Those are not like terms. They can't combine. So there's nothing I can do here. Now, there's a variable, the k, is on both the left and the right side of the equal sign. I'm going to say the easiest way to do this is to always bring the variables to the left. So the 7k is already on the left side of the equal sign. It's where we want it. This 4k needs to come across the equal sign. It is currently a positive 4k. So to take a positive term and move it across an equal sign, we must subtract it from both sides. So we will subtract 4k. On the left side, 7k minus 4k is 3k. And on the right side, the 4k minus 4k cancels. We moved it, leaving just the 15. And now this is a one-step equation. I hope we can all see quickly. We would divide both sides by 3, and k is 5. First thing I want you to do on every problem, draw a box around the left and right sides and ask yourself, are there like terms to combine? In the left box here, we have a 5x and a negative 2. Those aren't like terms, so I can't do anything there. In the right-hand box, I have a 3x and a positive 4. Those aren't like terms, so I can do nothing there. First thing I'm going to do is bring all of my variables to the left side. So I'm going to subtract 3x from each side. 5x minus 3x is 2x. We didn't do anything with the minus 2, so it's still there. And on the right side, we now just have this 4. Now I'm going to take the number terms and push them all to the right side. So this minus 2 is going to go across. This is a two-step equation that you're looking at now. We should be pretty comfortable dealing with these at this point. We're going to add 2 to each side, and that'll get us 2x equals 6. And of course, we will then divide both sides by 2 to get x being 3. Next up, distribution. Anytime there's an operation in parentheses, so y plus 6, that's an operation. That is y plus 6. We must distribute the number outside. We have to take this 2 and multiply it to both the y and the 6. 2 times y is 2y. 2 times 6 is 12. And that's that. Now if we draw our boxes, which I'm not going to be able to erase this time, but that's not a problem. In the left-hand box, I have 2y and 12. Those aren't like terms. They can't combine. In the right-hand box, I have 3y. That's by itself. I can't do anything with it. So now we just bring all the variables to the left side. So this 3y is on the right. It's got to come over. 2y minus 3y is negative 1y. We didn't touch the plus 12. And on the right-hand side, we got rid of what was there, which means there is nothing left. But we have to represent nothing with 0. We can't just write absolutely nothing down. We still have to have an equal sign, and you have to equal something, so if there's nothing left, nothing is 0. Now we will take the number term, this positive 12, and subtract it from both sides to move it. So negative y equals negative 12. And you're not allowed to have negative y, so we will divide both sides by negative 1, essentially flipping the sign of both. And that gets me y equals 12, the solution to the problem. Next problem is beefy. It's got a lot. The first thing we have to do is take this negative 2 and distribute it to the parentheses, which means this entire clump of stuff is going to stay as it is, 3 minus 5b plus 2b. On the right-hand side, that first negative 2 is still there, and now we start multiplying. Negative 2 times 1 is negative 2. Negative 2 times negative b is positive 2b. Box both sides. In the left-hand box, there's a negative 5b and a positive 2b. Those are like terms. They can be combined. This side is actually 3 minus 3b, because negative 5b plus 2b is negative 3b. In the right-hand box, there's a negative 2 and another negative 2. They can be combined. Negative 2 minus 2 is negative 4. The 2b is just there. Now we can start moving things across the equal sign. Again, I bring my variables to the left, so I will take that positive 2b. I'm going to subtract it from both sides. That's going to get me 3 minus 5b equals negative 4. We will subtract 3 from both sides. Remember that 3 is positive. That'll leave us with negative 5b equals negative 7. And we will divide both sides by negative 5 to get b equals negative divided by a negative is positive, so it is just 7/5. Remember, in Algebra 1, we will leave our improper fractions as improper fractions. We're not going to bother changing those to mixed numbers. We're not going to make this 1 2/5. We're not going to make it 1.4. We're going to leave it as 7/5. And looks like I got 2 more. So, no distribution to do here, so let's box stuff off and combine like terms. X minus 6x is negative 5x. The plus 4 doesn't have anything to combine with. On the other side, 6 minus 2 is 4, and the negative 5x doesn't have anything to combine with. First step here now is to bring all of our variables to the right side. So this negative 5x will be moved by addition. Negative 5x plus 5x is nothing, so we have 4 equals 4. That, of course, is true, which means there are infinitely many solutions. You could pick anything you wanted for x and put it in, and this equation would be true. So if you're solving something out and you get a true statement, you get infinitely many solutions. Last example, again, no distribution, so let's box things up. We can see by boxing up on the left-hand side now, I've got a negative 8x and a 9x in that box. Those are like terms, so let's combine them. Negative 8x plus 9x is just x. The plus 6 is still there. The right-hand box, those aren't like terms, so it just stays the way it is. We will bring our variables to the left by subtraction this time. X minus x is gone. That leaves me with 6 equals negative 17. That, of course, is not true, which means there is no solution here. There is no number you could plug in for x that would make this particular equation true.